right, turn to page 295, starting chapter 5. Chapter 5.1. It should be on page 295. All right, the first thing we're going to talk about is something called a mid-segment. A mid-segment is a segment that connects two midpoints of a triangle. Okay. So we're going to have to remember what a midpoint is. Okay. Remember, a midpoint is the point in the middle of a segment. Right? It connects, divides a segment. So if we have a segment here, midpoint is the one in the middle, and it divides our segment into two congruent segments. So it makes it, instead of being AB, it tells us that AM and MB are congruent. They're the same. Right? So a mid-segment is that segment that connects two of these midpoints in a triangle. So let's draw a triangle. Right. Let's label that triangle ABC. Right. So in order to draw a mid-segment, the first thing that we're going to need to do is we're going to need to find where the midpoints are. Okay? So the way that we would find a midpoint would be we could just take a ruler and measure, okay, and find the point in the middle. So that one would be about right there. Midpoint of AC would be about right there. And the midpoint of BC would be about right there. Okay? Let's label those points E, F, and G. Alright? So if we want to draw one of our mid-segments, okay, it says it's a segment that connects two midpoints. So it connects two of these points, E, F, and G. Let's just draw that mid-segment. Okay? EF, that is a mid-segment because it connects two midpoints, E and F. All right? So, with a mid-segment, we have a mid-segment theorem. It's theorem 5.1. The mid-segment theorem. Okay? And the mid-segment theorem tells us two things. Okay? Number one, it tells us that a mid-segment is parallel to the third side of the triangle. Okay? So what does that mean? Right? Well, first of all, looking at our mid-segment, it uses two of the sides. It uses this side AB and it uses this side BC. Okay? So the third side, when it says the third side, it's talking about this side that it's not using, the other side. Okay? So, number one, it says a mid-segment is parallel to the third side. All right, so that tells us that EF, segment EF, is parallel to segment AC. Right? So we know that EF parallel to AC. Right? The second thing that it tells us is that a mid-segment is half of the third side. So not only is EF parallel to AC, but it's also half of AC. Right? So we could write an equation that says EF equals 1/2 AC. Okay? Now let's look at AC a little closer. We know that we said that G was a midpoint. Okay? So since it's a midpoint, we know that AG and GC have to be congruent. Okay? They're congruent because G is a midpoint. Right? Now, I also know that since this is a midpoint, I know that AG is half of AC, right? This, AG, is half of the whole thing. So if AG is half of AC, and EF is half of AC, then that tells us that EF is congruent to AG, which is also congruent to GC. So all three of these segments are going to be congruent. Right? EF, AG, and GC, they are all going to be congruent to each other. So if EF was 8, AG would be 8, and GC would be 8, and then AC would be 16. Okay? All right, that's with one of our. That's just one of our mid segments. Let's look at another mid segment. Let's look at GF, mid segment GF. Okay? We know that GF, segment GF, would have to be parallel to AB. Okay? Because AB would be the third side. All right? So I know that those two are parallel. All right? I also know, because of Theorem 5.1, that GF is half of AB. Okay? GF is half of AB. And just like we said earlier, we know that AE and BE are the same, so GF would have to also be the same. Okay? Because if BE is half, and AE is half, and FG is half, that means they're all going to have to be the same. All right? Then if we look at our third and final mid-segment, EG, we know that EG is going to have to be parallel to BC, because BC would be the third side. All right? So then we know these are parallel. Okay? Another thing that we know is that EG is half of BC. Right? And just like our other two cases, we know that BF and FC are congruent because they're halves, and then EG would have to be congruent to those also. Right? So we kind of got a lot of markings on here, but you should know that a mid-segment, we know two things about it. Number one, it's parallel to the third side, and number two, it's half of that third side. Okay? All right, mid-segment theorem. There you go. All right. Other thing we're going to talk about in this section is something called a coordinate proof. All right. Now, a coordinate proof is not as bad as it sounds. Okay? If you look on page 296, you'll see the definition of a coordinate proof. Okay? Basically, in a coordinate proof, we're going to put shapes on a graph, okay, and we're going to use variables or letters in place of the coordinates. Okay. So let me show you an example. If we had, let's say we've got this graph here, and we've got these 3 points. Okay, let's say this one's at 3, 0, this one's at 0, 2, and here's 0, 0. Alright? If we have these if we have these 3 points, and you may have a question that says, what are the coordinates of the 4th point in the rectangle? Right? So we have 3 points of a rectangle, right here, 1, 2, 3, and we want to find the 4th point, which is going to be somewhere in this area. We want to find the coordinates of that point. Right? Well, what we're going to do to find that is our x value, we're going to go over this much, which is 3. And we're going to go up this much, which is 2. So the coordinates of this would be 3, 2. And that would give us a rectangle. Okay? Now that was pretty simple. Right? In a coordinate proof, this would be an example of a coordinate proof. Like so. Let's say that the coordinates of this are 0, k. Right? Here's 0, 0. And the coordinates of this point are h, 0. Okay? If we wanted to find the 4th point, which is going to be somewhere around here, we're going to take the x value this way, which happens to be h, and we're going to take the y value this way, which happens to be k. So the coordinates of our point would be hk. Now you can use any letters that you want to. It doesn't have to be h, k, it can be a through z, it doesn't matter. Okay? But in this case, our x value is h and our y value is k, so this is going to be the coordinates of our 4th point. Okay? Alright? You're also going to be asked to do something like so. A question that you might have would be to put this figure on the graph in a convenient way. Right? And what that means is you're going to have a graph. And here will be an example. You want to put a right triangle, okay, and one leg A, is 3 units long, and leg B is 2 units long. Okay? When it says to put it on the graph in a convenient way, it means that we're going to use the origin 0, 0. Alright? So we know that we're going to have one point right there. In order to make one of our legs, one of our sides, be 3 units long, let's think about where we would put one of our points in order for it to be 3 units long. Okay? I would put it 1, 2, I would put it right there. Because now this point is at 0, 3, and I know that this leg of my triangle is 3 units long. Okay? So I've got this leg that's 3 units long. Now I need a leg that's 2 units long. So now I'm going to go over 2 to right here. And the coordinates of that point would be at 2, 0. And I know that that leg is 2 units long. Okay? So if I connect my dots, there I have a right triangle, okay, with one leg that's 3 units long and another leg that's 2 units long. You're going to be asked to do that. Not super difficult. Okay? Alright, so quick review. Coordinate proof. In a coordinate proof, we put these shapes on a coordinate graph, okay, and we use variables in place of the coordinates. Right? Mid-segment. This is the more important part. A mid-segment. get it right. Okay, a midsegment is a segment that connects two midpoints of a triangle. So in order to draw a midsegment, you're going to have to find the midpoints and then you connect them. That's how we find the midsegments. Okay? And the midsegment theorem tells us two things. A midsegment is parallel to the third side, like we talked about. EF is parallel to AC. And the second thing it tells us is that a midsegment is half of the third side. So EF equals half of AC. All right? Okay, that's it for 5.1.